These are every major level of the ocean, from the bright surface to Challenger Deep, the deepest known point on Earth. Sunlight Zone. We begin in the only ocean level where sunlight is strong enough to support most plant life. The sunlight zone starts at the surface and reaches down to about 200 meters, or 650 feet. This thin upper layer contains most of the ocean life people recognize: coral reefs, sea turtles, dolphins, sharks, tuna, and huge schools of fish. Sunlight allows phytoplankton, seaweed, and other ocean plants to make food through photosynthesis. Phytoplankton may look like tiny floating dots, but they support much of the ocean food chain. Small animals eat them, larger animals eat those animals, and the chain continues all the way up to giant predators. Near the surface, waves mix oxygen into the water. Temperatures are also warmer than in the deep ocean. Together, light, warmth, and oxygen make this the busiest level of the sea. It is also where humans do almost everything in the ocean, from swimming and fishing to shipping and diving. Yet this familiar layer is only a thin roof above a much larger world. But even here, the ocean changes quickly. Red light disappears first, then orange and yellow fade away. The deeper we go, the world becomes darker, colder, and more blue. By 200 meters, there is not enough sunlight for normal photosynthesis. The bright ocean is now above us, and we enter a level where daylight is still visible, but barely. Twilight Zone. Leaving the sunlight zone behind, we enter the twilight zone, also called the mesopelagic zone. It stretches from about 200 to 1,000 meters, or roughly 650 to 3,300 feet below the surface. There is still a small amount of light here, but it is too weak for plants to grow. Food must fall from above, swim down from the surface, or be hunted in the darkness. This is where many ocean animals begin producing their own light. The process is called bioluminescence. Small glowing spots can help an animal attract prey, confuse predators, find a mate, or disappear against the faint light above. Lanternfish, hatchetfish, jellyfish, and many squid live in this zone. Some have huge eyes for collecting the last traces of sunlight. Others have silver bodies that reflect light and make them harder to see. Every night, an enormous number of animals rise from the twilight zone toward the surface to feed. Before sunrise, they return to deeper water. This daily movement is considered the largest animal migration on Earth, even though most people never see it. The pressure also rises fast. At 1,000 meters, it is around 100 times greater than at the surface. A normal scuba diver cannot come anywhere close to this depth. Reaching it requires a strong submersible or an unmanned vehicle designed to resist the force. And at the bottom of this zone, the final trace of sunlight disappears. From this point down, daytime and nighttime mean exactly the same thing. Midnight Zone. Once sunlight is completely gone, we enter the midnight zone, or bathypelagic zone. This level reaches from about 1,000 to 4,000 meters, or 3,300 to 13,000 feet. The water is close to freezing, the pressure is crushing, and the only natural light comes from living creatures. Food is difficult to find, so many animals here are built to save energy. They move slowly, wait for prey, and avoid wasting effort. Some have enormous mouths and expandable stomachs, allowing them to swallow almost anything they manage to catch. The anglerfish uses a glowing lure to bring prey close to its mouth. Dragonfish have long teeth that remain visible even when their jaws are closed. Some animals are black or dark red because red light cannot reach this depth. In the midnight zone, a red body appears almost completely black. Large animals also visit this level. Sperm whales can dive deep while hunting squid, but they must eventually return to the surface to breathe. For humans, this environment is instantly deadly without a protected vehicle. The darkness is total, and the pressure can crush equipment with even a small weakness. But eventually, many parts of the ocean reach the seafloor. Below 4,000 meters, we enter a vast, cold landscape that covers a huge part of our planet. Abyssal Zone. After passing through the midnight zone, we arrive in the abyssal zone, usually found between 4,000 and 6,000 meters deep. The name comes from the word abyss, meaning a place that seems endless. Much of this level is made of abyssal plains, wide, flat areas of seafloor covered in soft mud. They may look empty, but life is still present. Sea cucumbers slowly move across the bottom. Brittle stars spread their arms over the mud. Small crustaceans search for scraps. Microbes live inside the sediment and use whatever energy they can find. Most food arrives as marine snow. This is a slow fall of dead plankton, waste, dust, and tiny pieces of organic material from the upper ocean. By the time it reaches the abyss, much of its energy has already been used by animals above. A rare, large meal, such as a dead whale, can change everything. A whale fall may feed deep-sea animals for years. First come scavengers, then worms and smaller creatures, and finally bacteria that break down the bones. Some parts of the deep sea floor also contain hydrothermal vents. Instead of using sunlight, life around these vents depends on chemical energy coming from inside Earth. The abyss already seems like the bottom of the world, but in a few places, the seafloor suddenly drops much farther. Those narrow cuts in Earth lead into the hadal zone. Hadal zone. When the abyssal plain falls into a deep ocean trench, we enter the hadal zone. It begins at about 6,000 meters and continues to nearly 11,000 meters below the surface. The word hadal comes from Hades, the underworld of ancient Greek mythology. The name fits. There is no sunlight. The temperature sits just above freezing, and the pressure can exceed 1,000 times the pressure at sea level. This zone does not cover the whole ocean floor. It exists mainly inside deep trenches formed where one tectonic plate moves beneath another. Life here must survive conditions that would destroy most surface animals. Hadal snailfish have soft bodies without heavy bones. Amphipods, which look like small shrimp, search the trench floor for food. Microbes survive inside the mud and rocks. Animals at these depths cannot simply contain normal air spaces. The pressure would crush them. Their bodies use special proteins and flexible structures that continue working under extreme force. Food is still limited, but trenches can collect material sliding down their steep walls. In some places, this makes the bottom more active than the flatter abyss above. As we continue downward, the trench grows narrower and the pressure becomes even more extreme. Then, near the southern end of the Mariana Trench, the depth meter approaches 11 kilometers. There is only one final stop. Challenger Deep. At the bottom of the hadal zone lies Challenger Deep, the deepest known point in the ocean. It is located inside the Mariana Trench in the western Pacific Ocean. Modern measurements place its deepest point at about 10,935 meters, or around 6.8 miles below sea level. If Mount Everest were placed inside Challenger Deep, its peak would still remain more than 2 kilometers underwater. The pressure at the bottom is more than 1,000 times the pressure at the surface. It is similar to placing several tons of weight on every square inch of a vehicle. Only a small number of crewed missions have reached this depth. The first was the bathyscaphe Trieste in 1960. It carried Jacques Piccard and Don Walsh to the bottom. Decades later, new submersibles returned with better cameras, stronger materials, and improved mapping tools. The descent takes hours. During that trip, the view outside changes from blue to black long before the vehicle reaches the bottom. Outside the vehicle, there is no sunlight, no plant life, and almost no visible movement. The seafloor is covered in pale sediment, while small animals and microbes survive under conditions once believed to be impossible for life. Challenger Deep is deeper than any other confirmed point in the global ocean. But it is not the center of Earth, and it is not even close. It is only a narrow cut in the planet's outer crust. From the bright sunlight zone to this dark floor, the ocean changes from a warm world powered by the sun into a freezing world powered by falling food and chemistry. The full journey covers almost 11 kilometers. And even now, much of what lives along that journey has never been seen, named, or fully understood.